Hello all, welcome back to the student blog. In this series of Azure AZ900, uh, like we discussed in our previous videos, like Azure cloud concepts, core architectural components of Azure, Azure compute and networking services. And in this video we'll be looking at Azure storage services. So let's begin. So type of like Azure storage services contains like Azure storage accounts, type of Azure storage accounts, general purpose storage accounts, like tables, queues, file storage, blobs, Azure managed disks, Azure storage redundancy, Azure storage services, data migration options, file movement options. We'll be looking at one by one. So like we will be discussing about Azure storage accounts first. So Azure storage is a Microsoft managed cloud storage service that provides high availability, durable, scalable and redundant storage at a fraction of the cost if you were to manage it manually. So the very first thing we need to do is to create a Azure storage account. A storage account provides a unique namespace for your Azure storage data that's accessible from anywhere in the world via HTTP or even HTTPS. To use any storage type in Azure, you first must create an account in Azure. After creating an account, you can transfer data or from services in your storage account. Create a storage account to store up to 500 TB of data in the cloud. Use the Blob Storage account and the hot or cold access tiers to optimize your cost based on how frequently your object data is accessed. So like storage account contains all these services like blob, table, file, queue and even premium storage. So we'll discuss about types of storage accounts. So we have a standard general purpose v2, so which covers like which all come under is a blob, file share, queue and tables. So recommended for most scenarios using Azure storage. If you want to support for NFS in Azure files, use the premium file shares account type. So when you give AZ900 exam, you will get such type of questions based on these two, like what type of general purpose, what type of like what type of file system you'll use for NFS. So like such type of questions. So next is a premium blobs. So premium storage account type for blobs and append blobs, recommended for scenarios with high transaction rates or that use smaller objects or require consistently low storage latency. So premium file shares like a premium storage account type or file shares only, recommend for enterprise or high performance scale applications. Use this account type if you want a storage account that supports both SMB and NFS file system. So last but not the least is premium page blobs, premium storage account type for page blobs only. So we'll discuss one by one, in general purpose storage accounts. So a general purpose storage account provides a space where it gives you access to blobs, queues, files and tables. All these services is in a unified account. A general purpose storage account can be used to store object data, can be used as a NoSQL data store. You can be used to define and use queues for message processing and set up file shares in the cloud. So as mentioned, like 4 types: tables, queues and file storage and blob storage. So first we'll discuss about the tables. So storage service stores large amounts of data structures. The service is NoSQL data store, which accepts authenticated calls from inside and outside the cloud, Azure cloud. Azure tables are ideal for storing structured non-relational data. So this is a sample table. I just mentioned it, how it uses it. So next is queues. Azure Queue Storage is a service for storing large amounts of messages that can be accessed from anywhere in the world via authenticated calls using HTTP or HTTPS. A single queue message can be up to 64 KB in size, and queue can contain millions of messages up to the total capacity limit of storage account. So yeah, this is a sample like how it works. I just put it here. So this is the account, and this is the incoming and outgoing queues and messages stored. So next comes file storage. So a file storage share is a SMB file storage in Azure. All directories and files must be created in a parent share. An account can contain unlimited number of shares, and shares can store an unlimited number of files up to 5 TB total capacity of the file share. So when you create like a file storage, like you need to go to the where we need to do it, create it, like you need to go to Azure portal, and if you see here Azure services storage accounts, you will click on it and you will create a new account, and then you can create the required storage. So lab, we will do labs when we go for like architecture level of courses that will start shortly. So this is completely a theoretical course which covers Azure 900 exam. So keeping in that, I'm just preparing this, I'm just teaching this. So next comes blobs. So Azure Blob Storage is a service that stores unstructured data in cloud as objects as well as blobs. Blob storage can store any type of text or binary data such as document, media file, or application installer. Blob storage is also referred to as a blob object storage. So blob storage accounts are specialized in storing blob data and can also be used to choose an access tier, which allow you to specify how frequently data in the account is accessed. You can choose an access tier suitable for your storage, which suits your expenses. So blob storage is ideal for serving images or documents directly to a browser, storing files for distributed access, streaming video and audio, storing data for backup and restore, even disaster recovery and archiving, storing data for analysis by an on-prem or Azure hosted services. So there are two types of access tier, that is hot and cold. So hot, like hot is like this access tier grants us the lowest latency possible, hence it should be used with data which is frequently accessed. Naturally, since it offers low latency, it is more expensive, just keep in mind. So cold is like this access tier is less in performance than the hot access tier, that is offers higher latency than the former access tier. That being said, it comes with a lesser price tag and hence can be used for data which is less frequently accessed. So next comes Azure managed disks. So Azure managed disks are block level storage volumes that are managed by Azure and used with Azure virtual machines. So managed disks are like a physical disk in an on-prem server, but those are virtualized. With managed disks, all you have to do is specify the disk size, disk type, and provision the disk. Once you provide the disk, Azure handles the rest of the things. So the availability type of disks are ultra disks, premium SSDs, standard SSDs and standard hard disk drives. So highly durable and available. Like managed disks are designed for 99.999%, that is three nines availability. So managed disks archive this by providing you with 3 replicas of your data, allowing for high durability. So simple and scalable VM deployments are like using managed disks. You can create up to 50,000 virtual disks of a type in a subscription per region, allow you to create thousands of VMs in single subscription. So integration with availability sets. Managed disks are integrated with availability sets to ensure that disks of VMs in availability set are sufficiently isolated from each other to avoid a single point of failure. So disks are automatically placed in different storage scale units, so called stamps. So for example, if you say you have an application running on 5 VMs and the VMs are in availability set, the disk for those VMs won't all be stored in same stamp. So if one stamp goes down, the other instance of the application continues to run. So next comes Azure backup support. Currently Azure backup support disk sizes up to 32 terabytes disk. So it's huge. So next, upload your VHD. How it works is like a direct upload makes it easier to transfer your VHD to an Azure managed disk. So next comes Azure Storage Redundancy. So yeah, I know this is theory, but when you do practicals and you know somewhat about these terminologies and about what all this, it will be easy for you to work when it comes to practical sessions. That is the reason I'm going more theory, but we don't have an option. We have to learn this first before we go to practicals or labs. So next comes Azure Storage Redundancy, that is local redundant storage. So local redundancy storage, that is LRS, replicates the data 3 times within a storage scale unit, that is inside a data center. You can see here. So we have 3 replicas or 3 copies. So the data center residing in the region where we create our storage accounts, a write request returns successfully only when it has been written to all 3 replicas. Each of these replicas reside in separate fault domains and update domains within one storage scale unit. So local redundant storage is the lowest cost redundancy option and offers the least durability compared to other options. LRS protects your data against server rack and disk failures. However, if a disaster such as fire or flooding occurs within the data center, all replicas of the storage using LRS may be lost or unavailable or unrecoverable. To mitigate this risk, Microsoft recommends using zone redundancy or zone redundant storage, ZRS, or geo redundant storage, that is GRS, or geo zone redundant storage, that is ZZRS. So local redundant storage replicates the data 3 times within a single data center in the primary region. LRS provides at least 11 nines of durability, that is 99.119% of objects over a given year. So let's discuss about zone redundant storage. So if this is completely local, okay, so some fire happened or some flood or tsunami came, then you don't get the data. So in that case, we'll go for next option to make our data available, that is zone redundant storage. So in the zone redundant storage, like you are able to see 2 available zones and 3 available zones with 3 copies on each zone. So zone redundant storage replicates your data asynchronously across data centers with one or two regions in addition to storing 3 replicas similar to LRS, thus providing high durability than LRS. Data storage is ZRS is durable even if the primary data center is unavailable or unrecoverable. So one goes down or one completely filed or something happened, then also you will have 2 copies available. So Microsoft recommends to use ZRS in the primary region for scenarios that require high availability. ZRS is also recommended for restricting replication of data within country or region to meet data governance requirements. For availability zone enabled regions, zone redundancy storage replicates your Azure storage data asynchronously across 3 Azure availability zones in the primary region. So zone redundant storage offers durability for Azure storage data objects of at least 12 nines over a given year, that is 99.12%. Previously it was 9 nines and this is 12 nines. So again, the other option is zero zone redundant storage. What happened if complete state got flooded or something happened? So in that case, geo zone redundant is helpful. So zero redundant storage (GRS) replicates your data to a secondary region that is hundreds of miles away from the primary region. If your storage account has GRS enabled, then your data is durable even if the case of complete regional outage or disaster in that primary region is not recoverable. For example, let's take a simple example like you have you have a zone like in Boston, and you have a zone in California. So if Boston had a snow bomb or snow tsunami, something like that, snow bomb lanes complete, no service will be available, no power supply, such type of scenarios, still you have a data center in California where there is no, it's a good weather, we don't have any effect there, so obviously still you have an copy of your data available, and still it's available. So GRS copies your data asynchronously 3 times within a single physical location in the primary region using LRS. It then copies your data asynchronously to a single physical location in the secondary region, which is paid one, using LRS. GRS offers durability for Azure storage data objects of at least 16 nines, that is 99.69% over a given year. So this is a simple a picture to make understand, like this is a GRS and this is a local availability zones, LRS. So it's replicating, geo replication is in progress to the different region. So next comes read access to data in the secondary region. So geo redundant storage with GRS or GZRS replicates your data to another physical location in the secondary region to protect against regional outages. Within an account configured for GRS or ZGRS, data in the secondary region is not directly accessible to users or applications unless a full failover occurs. So the failover process updates the DNS entry provided by Azure Storage so that the secondary endpoint becomes the new primary endpoint for your storage account. During the failover process, your data is inaccessible. After the failover is complete, you can write data to the new primary region. So if your application requires high availability, then you can configure your storage account for read access to the secondary region. When you enable read access to the secondary region, then your data is always accessible to the read from the secondary, including in a situation where the primary region becomes unavailable. So read access geo redundant storage or read access geo redundant storage can configuration permit read access to the secondary region. So this is not automated. Sometimes you need to configure it manually. So because there is a caution like data is replicated asynchronously from primary to secondary. The secondary region is typically behind the primary region in terms of write options. If a disaster where to strike the primary region, it's like the some data would be lost. Like obviously, like from primary to secondary, the data sync will happen based on the frequency. Sometimes if primary data center went down or primary site is down, so you may lose some data, minute data, so that won't be available on secondary. Based on the sync, you may have lose some data. That's what it was saying. So next comes Azure Migrate. So Azure Migrate is a service that helps you migrate from an on-prem environment to the cloud. So Azure Migrate functions as an hub to help you manage the assignment and migration of your on-prem data center to Azure. So it provides the few things like unified migration platform, assessment and migration. So a single like unified migration platform is a single portal to start, run and track your migration to Azure, and an assessment and migration is an is the Azure Migrate Hub. You can access and migrate your on-prem infrastructure to Azure. So we will be working on these tools when we do labs. So this picture you can see here, this is on-prem data center and this is Azure. How we are using a vCenter here, a VMware hypervisors. So using the tool Azure Migrate, we will be we'll be migrating our VMs or data to the Azure cloud. Okay, so integrated tools like Azure Migrate, discover and assessment, discover and access of on-prem servers running on VMware, Hyper-V or even physical servers in preparation for migration to Azure. So we will use Azure Migrate. So server migration, or even using the Azure Migrate, we can do server migration, migrate virtual machines, Hyper-V machines, Hyper-V virtual machines, physical servers and other virtualized servers and public cloud VMs to Azure. Like if you have any other Google Cloud or AWS, you can also, using the Azure Migrate, you can migrate that VMs from one cloud to another cloud. So even using the data migration assistant, like it is a standalone tool to assist like SQL servers. It helps pinpoint potential problems blocking migrations. So it identifies unsupported features and new features that can benefit you after migration, and the right path for the data migrations. So data migration assistant, this is what we use for SQL migrations. So Azure Database Migration Service, it mitigates the on-prem databases to Azure VMs. Sorry, it migrates on-prem database to Azure VMs running SQL services or even servers, Azure SQL database or SQL managed instances. So for web applications, web app migration assistant we will be using, and Azure App Service Migration Assistant is a standalone tool to assist on-prem websites for migrating to Azure App Services or Azure App Service. Use Migration Assistant to migrate .NET and PHP web apps to Azure. So next comes Azure Data Box. So for example, you have tons of data, like TBs of data, migrating that you have some challenges with internet or something. In that case, Azure Data Box will help. Azure Data Box is in a physical box. Okay, it looks like this. Okay, So we can borrow this from Azure. When we request for this Azure Data Box, they will send you this box in a courier in a safe and protected way. So you need to plug in and put this, you can see here data 1, data 2 ports. So these are management port and one more is data port 3. You can connect to your data center and directly you can copy the data. So Azure Data Box is a physical migration service that helps transfer large amount of data in a quick, inexpensive and reliable way. The secure data transfer is accelerated by shipping you a proprietary data box storage device that has a maximum usable storage capacity of 80 terabytes. So it's a huge. The data box is transported to the data center via a regional courier. A rugged case protects and secures the data box from damage during transit. So it comes in a rugged case. Like anyone who want to use, they can order this data box device via Azure portal to import or export data from the Azure. Even you can import or export. Once the device is received, you can quickly set it up using the local web UI and connect it to the network. Once you finish transferring the data either into or out of Azure, simply return the data box. If you are transferring data into Azure, the data is automatically uploaded once Microsoft receives the data box back. The entire process is tracked end to end by data box service in Azure portal. So you can see like the status of when they send it and when you send it back, you can see the complete information. So use cases like data box is ideally suited to transfer data sizes larger than 40 TB in scenarios with no to limited network connectivity. The data movement can be one-time, periodic, or initial bulk data transfer followed by periodic transfers. Some of the various scenarios where data box can be used to import data to Azure: one-time migration, when a large amount of on-prem data is moved to Azure; moving a media library from offline tapes into Azure to create online media library; migrating your VM form, SQL servers and applications to Azure. So sometimes scenarios will be like if your SQL VM is huge. In that case, migrating over the internet to Azure, it will take days, so hours, even days. So we cannot keep this production down at that time, right? So in that case, that will be helpful. So moving historical data to Azure for in-depth analysis and reporting using HD Insight. Initial bulk transfer, when initial bulk transfer is done using a data box, followed by incremental transfers over the network. So it's like there is tons of TBs of data. So initial transfer you can do it, and later it will be easy for incremental transfers over the internet. So periodic uploads, when large amount of data is generated periodically and needs to be moved to Azure. So few are the various scenarios where data box can be used to export data from Azure. So like a disaster recovery, when a copy of the data from Azure is restored to an on-prem network, it is typically a disaster recovery scenario. A large amount of Azure data is exported to data box, then Microsoft will ship the data box and data is restored to the on-prem in a short time. So security requirements, when we need to be able to export data out of Azure due to government or security requirements. So migrate back to on-prem or another cloud service provider when you want to move all the data back to on-prem or any other service provider who is giving for less price. In that case, you can export data to data box and migrate the workloads. So all these scenarios it will be helpful. So next comes Azure file movement options. So if you have few commands like azcopy. So azcopy is a command line utility that you can use to copy blobs or files to or from your storage account. With azcopy, you can upload files, download files, copy files between storage accounts, and even synchronize files. Easy Copy can even be configured to work with other cloud providers to help move files back and forth between clouds. So next is Azure Storage Explorer. So it is a storage like a standalone app that provides a geographical interface to manage files and blobs in your Azure Storage account. It works on Windows, even Mac or Linux operating systems, and uses Easy Copy on the backend to perform all of these files and blob management tasks. With the Storage Explorer, you can upload to Azure, download from Azure, or move between storage accounts. So next is Azure File Sync. Azure File Sync is a tool that lets you centralize your file shares in Azure Files and keep the flexibility, performance, and the compatibility of the Windows file server. It's most like turning your Windows file server into a miniature content delivery network. So once you install Azure File Sync on your local Windows server, it will automatically stay bidirectional, synced with your files in Azure. So like cloud service providers, with your cloud service providers. So these are all the hold on. So these are all related to storage, Azure Storage, and we will meet in our next video. I hope this is informative for you guys. Thanks for watching. Please do subscribe and like my videos, and also as always for any queries you can reach out to me on vstudentblog@gmail.com. Thank you. Bye bye.